Hi, this is now another video on the tutorial trees-based methods. This is a part of the lecture series Digital Economy and Data Analytics, and my name is Egon Furen, and I would like now to go on with random forests. Well, random forests are almost identical to bagging. The only thing that we actually have to do is that we now have to set the maximum number of features using the option max features. Remember from the lecture series that what we do with respect to random forest is that we are going to, well, use a subset of the total number of features that we have in our analysis, and we're going to do that completely randomly among the different bootstrap samples that we have. So apart from, say, sampling with replacement from the data set that we have, we are also going to, sample without replacement from the features that we have in our analysis. So that implies that what we're going to do next is that, again, what we are going to do is that we're going to import the random forest regressor, as we have already done with respect to bagging. But now what we need to do is that we have to set the maximum number of features. What we can do that by using this option that we have over here, max features, and we can, for example, set that equal to 50. That looks like a quite high number, but take into account that in our analysis, well, especially at the moment that we were using our dummies, we actually did in Lasso have actually a couple of hundreds different features. So then it implies that using only 50 features in total isn't that much at all. So then what we next have to do is to use doing the fitting process, and we're going to be able to do that by writing clf.fit, and of course then again we're going to use the x values from the training data set, which is based on this x train that we have over here, and we're going to use this y train that we have over here, which is the y values of our training data set. Well, then again we can look then at the total program in order to look at cross-validation. Here we are only going to look at what we need to do at the moment that we're going to use out-of-bag samples, which is exactly the same idea as what we had in the previous video at the moment that we were looking at bagging. The only thing that we need to do is, of course, apart from the estimators that we have over here and all these other things that we have already introduced before, we also have to set the maximum number of features. Well, that we are going to do with respect to just setting it here equal to 75. I have done some trial error myself, and I actually found out that setting the maximum features equal to 75 more or less is the best choice. So I haven't done here completely cross-validation, but because if we would like to do this really good, then we're going to do cross-validation both with respect to the maximum number of features as well as the maximum depth or the optimal depth that we are going to have. But that is not what I have done here. Cross-validation is only going to be based on the optimal depth, and in that sense it looks almost identical to what we have already seen before. Here we are going to have the random forest regressor, and where we are going to have, apart from of course the estimators, we also are going to have the maximum number of features, being in our case equal to 75. Well, apart from that, everything is exactly the same as with respect to bagging, so I'm not going to say too much about that. And then in the end, we are going to have here again our random forest regressor, and after we have already gotten the optimal depth, also here everything is exactly identical to what we have already seen before, and then we can actually do the fitting process already based on the optimal depth as we have over here, and can calculate the MSE as well as the R squared in the test sample. And again, if we are going to do that all correctly, then we're going to have a very tiny improve with respect to the MSE as what we have seen before, but because of the fact that now the test risk is going to be equal to 0.0249, and the corresponding R squared in the test sample is now going to be equal to 0.9137. This is actually based on n estimators equal to 100, take into account that at the moment that I'm going to have n estimators equal to 1,000, there's not that much of a difference. Most likely there's going to be a little bit of improvement, but I haven't actually done it here.